Welcome everybody to the Transitional Artificial Intelligence Research Group seminar series. This week we have Saman, and Saman will be presenting his talk on the area of recommender systems. And we had the opportunity to supervise Saman, and thanks to Dr. Pavel here and the team for completing this research. Someone will be submitting his PhD thesis next month, and we look forward to his talk. Thank you.
Thank you. Thank you. Hello, everyone. Our PhD thesis is a multiview graph dual attention deep learning and contrastive learning for multi-criteria recommender systems. Outline is including the introduction, literature review, definitions, methodology, results, and discussions. Firstly, we need to introduce some concepts, including recommender system. Recommender system is a personal suggestion for user based on the preference, including behavior or rating the items, the address, and track the user preferences according to the behaviors. And in the other side, we have a multi-criteria recommender system. Multi-criteria recommender system, including the items. Some items, the items have a multiple features. For example, is the hotels items, including the several features for each item, and each user can rating every feature of these items. In the other concept is a graph neural network uses deep learning and graph structure data for better representation, and with the machine learning methods, we can enhance the representation of this graph. We have a multi-view graph attention mechanism. We have a multi-view is a combined with this when we have a multi-view. Multi-view is the different views and how can finding or coherence or these integrations, several views based is the one attention mechanism. In the other side, we have a contrastive learning, and in this representation, we use the dual contrastive learning, including the local and global similarity. Local is the learn node level distinction based is the each view, and global that's based is the capture graph level patterns that are finding similarity between nodes in all of these graph. That means the local including finding similarity between nodes in each view and global in all of these graphs. We have a motivation of this our representation includes why using the multi-criteria recommendation, because we have some limitation of this traditional or single criteria recommender system, including focus on single aspect of rating of the user preferences, because single recommender system just can show this the one behavior of this the user. And in the other side, insufficient for items with multiple features in the single criteria, we cannot cover or support these items. In these important challenges in multi-criteria recommender system, including limited interpretability of deep learning models, data sparsity issues, complex user item relationships in these multiple criteria. Actually, in the previous work, we didn't have the multi-view formal criteria. That there's all of these criteria representation, but basically is one view, and we think this didn't have enough accuracy, because for each criteria or for each features we need to the special representation. And our method included better capture of local and global representation, integration of multi-views based on criteria, and enhanced representation learning in all of these graph based is graph neural network. In this when we want speaking about this graph attention, for example, in these figures you can shown is in the local attention we have a one graph that lies in this attention finding the attention scores between nodes. That lies, we can say this is each graph is one preferences of users, one rating of these users. That lies, I'm finding the attention for each view or each criterion. Then when finding the local attention for each view or for each graph, that we're using the global attention, including the several views, and finding the attention similarities between nodes based all of these views. For example, two users in this spatial view has a similar together, but in this next level, we should finding the preferences of this user in all of these graph or all of these view. That is, for example, when suggestion or recommendation one hotel to the user say that, oh, the cleanliness or price of this hotel is okay. But it is just one special criteria. When we analyze it in all of these, the criterion, for example, is the cleanliness, price, location, that right, and say finding the user, which user similar together in all of these the criteria or preferences. In this concept, other concept, we have a constructive learning. Constructive learning is the main and hot concept in this robust for the robust embedding. In the constructive learning, that is a self-supervised learning. That is based the constructive learning. We can using this positive pair. Positive pair means this is a similar embedding, near together, close together, and negative and unsimilar embedding that are far from here, that dissimilar. And we use from these two states, of the constructive learning, including local, finding the page similarity in each view, and page similarity in all of these view, called this the global constructive learning. In the literature review, we have two main sections based the single criterion methods or single criterion recommended systems. That writes, for example, the recently work, all of these are based on the graph neural network, deep learning, and MLP method, and including some recently research than deep learning and MLP, CNN, or convolutional neural network, and MLP or graph neural network, multiview, attention multiview learning. In the other section of this literature review includes the review the recently work-based multi-criteria model, including, for example, this work using the deep neural network, deep learning, tensor factorization. But in all of these, the work that writes for all of these the criteria using just one representation, and didn't any distinguishes or these the spread views or criterion-based representation. Where in the definitions, we can using this definition for multi-criteria recommended system, multi-criteria recommended system, big difference with the single criteria. Is this the defined the CC means the number of the criteria, and for each criterion, we using the spread representation. And when the U and V is the user and items. And we use from this the bipartite structure graph for this research, including, in the bipartite graph, we have a user in one side, in the other side, we have items. But the important notation is that we use the multiple weighted age between them. Each age shows this the one criterion of this the item. And the definition of this the BGGN matrix. That was in this BGN matrix include these two main sections. That was in this user item and this transpose update, and these the two other section is this the zero or empathy. But normalization, using the normalization for finally base is the degree of these the nodes and neighbors. Here. Network embedding, is a base a multi-view that raise each is a view depends the number of this criteria for each view. You generate this the special embedding. And overall, this is our structure, including firstly generate bipartite graph basis our data set. Bipartite graph is the multiple criteria that rise and converted each criteria to each view and generate or represent spread representation for each view that generate the LBGN matrix that rise and apply or using the local and global attention. For this local attention including each matrix that is, and global attention includes all of these the views or the main matrix that generate embedding base. In this other side, for each view, define the anchor point. Anchor point in the previous work usually definition randomly, but in our work we define the anchor point based is the cosine similarity that is, and selected is the anchor point based is the having the most similarity with other nodes in each view, and that after finding the anchor point in the next level, we define the constructive learning based and define the positive and negative that rise for each view that all of these fusion embeddings in one matrix, and then generate embedding and generate recommendation based is the generated embedding.
Could you get into the example?
In the here, example based.
An example of how to recommend the system application multi-criteria.
Yes. For example, we have a when we come in this university, we have a different objects. That was on one student, you are the master students, that the graduate student, you are lecture in the here. I am a PhD student, but we can generate the multiple views. That is because all of these, for example, when this is the stuff in the here, that right, and but we have a spread view, that right, and how can finding the similarity between students, between lecture, between staffs in the university? How can finding similarity? That is just we should representation, finding the firstly similarity. For example, firstly we should finding similarity between lecture together, students together, and staff together. That right. After finding similarity between them and define each view or each group for them, that right. In this next level, finding the global similarity for all of these the members in the UNSW. That right. Based is we can this is similar to our work. UNSW has a multiple features. That's right. Firstly, we define the similarity or representation for each feature. That's right, and then finding similarity or representation for all of these features of this UNSW. But for all of these members, UNSW is the shape or common source for all of these view. Is a data set. I don't know.
After you find the similarity.
Sorry.
What do you do after you find the similarity?
For this after finding the similarity, we can generate recommendation based on the similarity together. For example, we have two types of the similarity for two types of the recommendation. Firstly, we generate recommendation for each group. For example, generation recommendation for for lectures in the here, for staffs in the here, for students in the here. That is special for each groups. In the other step, we can generation recommendation for all of these the member of this university. Based is the finding similarity or based is finding the requirement. For example, when we come in here, all of these the members in the UNSW have the special requirement. That's right. Based on we can generate recommendation. In the next step, when compared, for example, University of Sydney, all of these the member in the UNSW has a special requirement or preferences compared with the, for example, I don't know, University of Melbourne or all of these Sydney. That's right. We have a two analysis. Based is firstly in the local requirement and global requirement. I don't know, is that good? Thanks. Then, when defined is the local attention depend to this each group or each views. That right. For example, finding the attention between this. In this easy or the means. What means attention score? Attention score is the, we can say this that each user that right has a special influence between co-worker. That for example, one students or lecture or I don't know staffs, all of these have a special influence in this university. That does, and by attention we can find in this influence score. And using this the influence score or attention score, this is the finding the similarity between them. After finding local attention, that is using the max pooling in the max pooling in the CNN or convolutional layers. That is for finding the global attention. That are using the local attention as an input to the pooling for finding the global attention. About this, the anchor point, I say the motivation about this the previous work based the random anchor selection, but we using the leverage similarity and heretical at the relationship between node. That right, and based is the highest neighborhood similarity. The equation for anchor point selection, that and anchor node selection after finding the average similarity between nodes using the argmax function for finding the anchor point. That means in the result we have a anchor points or anchor user or anchor nodes with this the highest similarity compared in the other nodes. After generate embedding in the here, we want robust embedding. That right, with this using the contrastive learning including two main function, local contrastive learning. Firstly, finding the embedding similar together in each view. In this global contrastive learning, that is finding the embedding similar together in all of these the graphs or all of these the university. That is, and at all using the total loss or the finally loss, including the three terms and yet one terms for this local contrastive learning. Global contrastive learning is using the regularization for this overfitting of this the result. After using the contrastive learning, just by using the fusion, that is collect or all of these the embedding in one function or in the one space, that is concat together with together, and then how defined is the recommendations? how generate recommendation, that we want using the utilize user preferences and behaviors based the cosine similarity between user embedding, that right, and it's including the multi-view graph attention model using the cosine similarity or finding similarity between embeddings. Then for evaluation models, we use two main data sets, including Yahoo movies. Each movie has a 4 criteria, and beer advocate each beer, including 4 criteria to that right, and generate embedding, and is using the evaluation flowchart. In the next step, that is preparation or model training and testing, and is they using the metric evaluation. Statistic of this our data set, including, for example, average reviver of this the user or these the items that for this beer advocate and Yahoo movie, the sparsity that is average criteria, both the 4 and variance in ratings. That using 2 metrics, including MAA and RMSA metrics for evaluation result. And we have a one flow chart for this our evaluation, including input the data set, generate embedding according proposed models that split data in the train set and test set, including the train set is the 80% and testing set is including 20%, but using for prediction using the SVR support vector regression function that address in the train set and train the SVR model in these fuse embeddings and general recommendation based prediction. And our train base is a cosine similarity or recommendation model that make prediction in the train set and test set that is using the standard deviation 30 that because all of these are result based, this is a 30 runs and calculated the mean or average of this the MAE or RMSE and this is standard deviation. And we have 2 types of this the baseline model, including traditional method and advanced method that all of these compared with proposed models, that right. And K parameters is a hyperparameters in this final loss function, including the alpha for this local constructive learning, beta for this global, and lambda is the regularization weights that does, and hyperparameter configuration including using the 0.1 to 0.9 weights that is for evaluation model based hyperparameters that is we have a 2 result that is, and this the best result is this alpha and beta equals 0.5 and both bigger from this lambda that is, and that means is this the for getting the best result the weight of the local and global consecutive learning should be as equal. And that about this in the next step we have the embedding dimension or embedding sizes that is, and evaluation model based is the different sizes of this the embedding is this the defined for the data set. You now with the increase the embedding size the model improve until 256 that's right, but after this we have a overfitting. For example, 4 5 1 1 2 we have a overfitting and the preference of this model decrease, and the best embedding size dimension or embedding size is a 256 dimension. And in the other side, based is ablation study. Firstly, we fix the test size. We fix the test size and define the several sizes for train section. That is including train section 40%, 60%, 80%, all of them. That 100 to the section of the percent of the tracer equals our model. And firstly, we remove the attention, global attention. We remove the global attention and evaluation model without the global attention section. And in all of these, the sizes, our model is a better and show the impact of this the global attention. In the next step, we remove global attention and contrastive learning, that right, and run model without them, and that is a based similar results that in all of these sizes proposed model so better and show the impact of this the attention and contrastive learning in the both data set. In the is this the using the in the other section we define this the or evaluation model based is a number of these criteria that right, for example, show this is the number of this feature of criteria for each item has how many influence in this result that right, for example, firstly run the model based on one criterion or try two criteria, and the best result related to the fourth criteria, and this each feature or each criteria of this item help to user for this increase the accuracy in the recommendation models. For evaluation study, we define this the other data set trip advisor that right, and evaluation model for this in the third data set, including the trip advisor data set, that's right, and using the lack of attention, lack of global and global attention and constructive learning, and our model again has a result, a better result compared with this them in this trip advisor. That is additional study for the trip advisor. And compared with these different criteria that are including 1, 3, 5, 7 criteria for trip advisor data set. Just the notice trip advisor data set has 7 criteria for each item. And this lastly, compare our model with other baseline model, including these the 12 models that right based the MAE or RMSC metrics in the Yahoo movies and Beer Advocate movie that right, and is the best result based is the CFM items in the here that right, but at all our model is a better in this the results. And we can in the discussion we can definition there's the several concept on view about these the results and including some evaluation and challenges. Firstly, bipartite graph is the multiple weight edges for criteria. Is this the novelty structure for multi-criteria recommender system as multi-view representation for user item relationship, local and global attention, and dual graph attention convolutional layer, and innovation LBD and agency matrix for each criteria, integration of multi-view information, dual attention and constructive learning, and enhanced node representation learning. Current limitation, our model certainly has some limitations too. That we have limited the real world scenarios analysis, data set diversity, constraint, hyperparameter sensitivity, because hyperparameter should be sitting with the manually. Is a one limitation, and the attention to need to the heavy space that or process as is, and it's one of these the limitation too, that is the sparse and bias view challenges is the important limitation in our model, and future direction we can using the dynamic hypergraph or hypergraph structure. Firstly, convert to our model to the hypergraph structure, and using dynamic, we can define dynamic based is the attention-based similarity, that is an advanced optimization techniques, adaptive hypergraph, and enhanced regularization, that a dynamic weighting mechanism, that a context-aware recommendation, that all of these we can using the future direction. Key achievement. Now our framework, that the integration of dual attention mechanism, enhanced personalization and accuracy for recommendation, effective handling of multi-view information, that right, and identify challenges, computational overhead, scalability consent, fixed agency matrix limitation, potential view biases, and the record Dr. Rahi, can I show the code or?
Yes.
Okay, thank you. Okay. Our code model in is the here. Firstly, and when described is our code that is including several main functions that are firstly using the reading data, that right, and define this the LBGN matrix that right in the here, but define this the graph attention for network embedding, graph attention class including two sections, local, that right, local in the here, that and finding the global attention based the average and using the pooling, that right, for them. And fusion embedding in this multi-view, that right, and then using the local constructive learning for each view, define this the anchor point and anchor node, that right, and then finding similarity between them, which each view, then using the global constructive learning in the here, that right, and all of these the retail fusion embedding in the here, that right, based robust embedding and then fusion, and these they're using the regularization hence and train the model in the here definition and define this the total loss in this the here including alpha, beta, and lambda or gamma in the here local constructive learning and global constructive learning, and definition recommendation based on the top models including the finding the top items with is the most similarity to users, and then in split data set including test size 2, that 22%, that right, and these for each section define this sprite file and save the result then, and define these the SVR models, and using the SVR model SVR in the here, that is learn the model based them, that right, and they create subset including the for these 30 runs the model, that right, and in the here, and evaluation subset, each subset, that right, and evaluation all of these the model based is the MAE or RMSC, and generate embedding or generate recommendation based that, and multiple runs, that right, in the here's also and is the main is the here, that right, and in this result is we have a, and the result is including, for example, for each data set, the result is this the multiple run in this the here for is the first they using the Katana server, that right, for all of these they have a this the result, sorry, this in the here result, that is the efficiency of this the CPU. And we have a for evaluation studies, we have all of these results based, for example, lack global attention. The code remove them, and result is I think here. Yeah, is the code of this chart and evaluation study. Thank you for your attention, and special thanks for my supervisor, Dr. Pavel and Dr. Rahid. Thank you.
Thank you so much. So we'll take some questions, right?
Of the attention, like, is it from like scale to the front? I saw that you use like softmax and then
And can you just
come a bit front maybe to ask the question?
Like about the attention.
Yeah.
Attention layer.
Scale to the front. How I saw that you were getting like integrating softmax like and other functions. I wonder what exactly.
Is the question about integrating different activation functions? And what is the need of that in the attention mechanism?
You know, firstly, just show this. Let me. And is the code is a better? I think definition is in the code is the better. Please 1 second. Is the here that is first in this class attention that is for each view defined is the attention score that is for each view is including local attention. That, for example, when we have we have several matrix that is, and for each matrix according the code finding the local attention that is between the nodes. It's okay until this step. Okay. After that is we have a local attention that is using, for example, in the here for define the global attention that is using the one pooling. That is one pooling is the getting or receive all of this the attention that is, and between them, for example, you can imagine one pool that is, and all of these the matrix input to the pool that is, and between them. Again, run again the attention based the average attention that is, and finding the attention between the together. For example, when finding the attention in the one matrix that is, then finding attention between two matrices with together that is, and convert all of these one big matrices. We have a different types of these local and global. Is the according the definition of our issues that we can, or this compare of this result how define the local and global attention is important compile attention in all of these the graph, and how or this how definition is or which definition is a better for you is depend to your issue. That's right. And this is the data set. All of these depend to the data set. But in our model, we using from this the pooling for define the global attention. Yeah, certainly.
Instead of cosine similarity, there's like consider similarity or a hybrid version.
And you know, we have a different similarity, you know, but the best ways for this the finding the having the most effective that is you should is the compile with together. That is cosine similarity or this the distance similarity that is, or no, or Jaccard similarity. But according my experience, certainly in this recommendation models, the cosine similarity has a better results. All of these are optional. Just you should test it with these functions or which ones is better using them.
Okay, thank you. Rodney has a question. He's
Yeah.
saying why he's not sure why you are distinguishing between local and global similarity.
Because our view based is we have a actually I say is a better. We have a two private and global. That's right. We have a private. What means private? What means, for example, staffs in this university has a special requirement or special similarity, and PhD students has a special requirement, or I don't know, interesting that is spread from this the requirement of this the lecture and stuff. In this the first level. In the second level, all of these the graph or all of these university according our example, that is the users or the members has some common requirement, that is, and we should consider to this requirement or this interesting or behavior in these the two level or two steps, and we had to define the local and global, and the periods work we couldn't representation all of these the not based on the multiple criteria, based is the one unique view. That right, because each view has a special details. That right, and finding the special details, we can go into the next step for finding the global details.
Okay, so let's go into this example of a university. So let's say that somebody is here who is not from machine learning that much or has less knowledge of machine learning. And some of the machine learning people do not really understand recommender systems because it's a deep learning people as well. You are using deep learning for recommender systems,
Yeah,
which is relatively new in the field of recommender systems for last 10 years. And you have Netflix and YouTube and others.
yes, you're right.
That they are all now using deep learning based recommender systems. So recommender systems, we want to say that it's not fully supervised learning, right?
Yes.
It is unsupervised learning and supervised learning together, right?
Yes, you're right.
So the thing with is in your example for the university, let's say you want to recommend, there's a set of criteria, and you want to recommend somebody which area to rent,
Yes.
right? Which area to rent. So you have a group of staff, you have a group of students and staff, a professional staff group will have their own requirements. The academic staff have their own requirements. They will give you certain, and
Yeah.
the criteria is based on how much money you are earning and how much distance you want to walk from the university, and the student groups, postgraduate students,
You're right.
undergraduate students, research students, they all have a lot of criteria in where to rank,
Yes.
right? So in this example, what is global attention and local attention?
And just this in continue speaking of the Dr. Rahid, just please imagine there's the Netflix. That's right. Netflix suggestion for the Australian people has a special movies. For Indian people has a special movies. That we can consider Australian or Europe, for example, I don't know, Germany or the India is a local. That's right. Local is a means. In this, for example, in here, Australian people, some movies has a special attention or is a popular just in the Australians. That's that in this local attention. And global attention, what means? If you remember, you suggested one movies, that's right. Some movies has a popular or special attention in all of these countries. That's right. When imagine we together, we can just finding difference between local attention and global attention, and how finding or how create relationship between together. That's right. And when using the recommendation movies, we can generate the recommendation to user support local popularity and global popularity. That is, for generate recommendation, we should consider both the items. I don't know if it's
Yes, okay, that's good. That's
That
good.
was a good one.
Yeah, like you see Indian movie, right? Three Idiots.
Yeah.
Quite
Yeah.
popular in India and then now quite popular in China.
Yes,
Also in US.
yes, you're right.
And you have the Dark Knight
Yes.
series from US,
Yes,
kind of popular in other places, but they have special attention
yes, you're right.
in the
Special
home
movies.
countries and even the different states. Anyway, so this was any other questions or
Yes,
comments
actually, question on the slide.
on
Yes.
the slide? Yes.
The results
This
that
slide.
tried the
Either
40%, 60%, 80%,
yeah.
and 100%. I want to ask a question.
Okay, please 1 second. Finding the table.
Yes, yes.
Oh, the here. Yeah.
I'm not clear on the 100%. Like, was it the splitting that you splitted 100% on train and test?
No.
Or I don't get it. It was not clear because that side was really.
In, I had this the your mistake that Dr. Rahid guide me. This
Yeah,
answer.
because that's how it was.
You know, in this table, is the table just based on the train section. 20% of the data set is the for the test section is the fix. And train section is split in this the 4 divided. That's right? Oh, train section. All of these is 100% means is the 80% of
Of
this
the
the
train.
yes, train
Oh.
section. You know, test section is the fix.
Ah.
Just test the code. This is the several section of this is just train.
Oh, yeah.
It's okay.
Okay.
That's
Yeah,
a
good.
bit confusing.
That's a good point because we wanted to show the effect on the
Train.
train size,
Yeah.
but the test size remained the same.
Same.
Right. So I just wanted to highlight that for the group, this is quite good GitHub repository and the
Yes.
code demonstration, and this is can be a standard and good example for us.
Yeah.
I'd like to sincerely thank Pavel there who guided in the code checkup and test process.
Yes.
And we have gone a long way with this project. Thank you, everyone.
Thank you
so
for
much.
you.
Okay.
Thank you. Thank you so much.